7.7. We are solving systems with inverses. So now we're going to see some of the applications. In fact, the last two problems in this section are going to give us real-life applications of matrices. Like, what are they used for? Why did they make them up? Everything in math is made up, and it's made up for the purpose of solving real-life questions. So we've been, here in the end of Chapter 7, we've been learning about matrices, which are things like this, right? Numbers in boxes, which were made up to help us describe real-life things. And when they made up matrices in the 1800s, at least they named them in the 1800s, they were using them way, way back before Christ, back in the BC era. Ancient mathematics work shows matrices. They didn't call them matrices till the 1800s. Anyway, enough with the history of math. These are matrices. So, and we've learned, in 7.5, we learned how to add, subtract, and multiply matrices. In section 7.5, right? We added two matrices together, we subtracted matrices, we multiplied matrices. So in math, whenever you make up something new, like matrices, boxes with numbers in them, you've got to make up the rules for how you add those things, subtract those new things you've made, and multiply those new things. So, and we already did that back in 7.5. And the adding and subtracting was supernatural. I mean, just regular, normal. And you just go entry by entry. You can only add or subtract matrices that are the same size, and it was really easy, really natural. Multiplying matrices was pretty darn weird. There were some specific rules about which ones can be multiplied and which ones can't, and how exactly you multiply matrices. Not the normal way we probably would have made it up. Why did they make it up so weird? Well, it turns out that's the most useful way for doing many things in physics, chemistry, engineering, biology, etc. So it was useful, even though it seems weird. So what operation do we have left? We've got adding, subtracting, and multiplying. We know how to add, subtract, and multiply matrices. What's next? Of course, dividing, right? So in this section, we're going to begin with how do you divide matrices? How do you do that? And to get to that question, we got to think about what the essence of dividing really is. When I take a number like 10 and I divide it by 2, right? 10 divided by 2. We know the answer is 5 because 2 goes into 10 5 times. Well, if you think about it, dividing by 2 is the same thing as multiplying by 1 over 2, right? Half of 10 is also 5. That's the same thing. So dividing, whether you write it as a bar or with a dividing symbol, either way, dividing is multiplying by the inverse, isn't it? A half is the inverse of 2. That's the inverse. So really, dividing is just upside down multiplying. It's multiplying by the inverse. Okay, so then if we're going to talk about dividing matrices, what we really need to talk about is what the inverse of a matrix is. Because dividing is nothing more than multiplying by the inverse. That's all dividing really is. Right? Just like subtracting is adding a negative, it's really not something totally brand new. Dividing's not something totally brand new. It's just like multiplying, but you're multiplying by the upside down, by the inverse. So to learn how to divide matrices, we have to learn what the inverse of a matrix is, and then we can just multiply by that inverse, and we will be dividing. So that's the issue then. If we want to learn to divide, we got to learn what an inverse is. So what is the inverse of a matrix? Well, here we go. That's what this section is all about. That's why it's entitled Inverses, Solving Systems with Inverses, because inverses is how you divide things. You multiply by the inverse, which we'll do some of that in starting, I think, on problem 5. So, all right, so how do we find the inverse of a matrix? It says find the inverse of matrix A. I'm going to give you a special formula. It's going to be kind of magical. Let's call these entries A, B, C, and D. So the inverse starts off with a fraction. 1 over, you multiply these two, A, D, subtract, multiply these two, B, C. So you put that big old fraction in front, and then you go back to the matrix, and you go back to this main diagonal, and you switch those two, put D here, A there, and take the other diagonal and put negatives in front of them. There it is. There's the formula. I'm going to do it on this particular problem. But there's the formula for how you find the inverse of a matrix. Which is, it seems kind of bizarre, doesn't it? Let's carry it out. So let's do it on this particular one. So in the front, we're going to have this fraction. 1 over AD. Now, it's all about the diagonals. So, it's A, B, C, D. So AD is this first diagonal right here. So that's, here, let me do this a little better on that. Okay, so this is A, B, C, D. So I'm going to multiply the main, we call this the main diagonal because it starts with the very first entry, upper left. Starts with the first entry in the matrix, main diagonal AD. 1 times 1 minus the secondary diagonal, the other diagonal, -3 times 0. And so what is that? That is 1 minus 0. That's 1 over 1. That's just 1. That doesn't do anything, okay? And that's kind of a weird one. Nothing happened. And then what do we do on the inside? On the inside, notice we take, let me go back to where it was again. A, B, C, D. See how we've swapped these two? You swap the positions of the main diagonal. Put a 1 here and a 1 here. Of course, it doesn't look like anything happened because they're both 1s. This is kind of a weird example. And then you change the signs. They don't move. B is still here and C is still there. B is still here and C is still there. But you'd put negative signs on them. You change their signs. So that'll be -0. That'll be -3. Right? Because it already had a negative, and then we're adding a negative. So that'll make it positive. So what's this going to be? This will be 1. -0 is just 0. It doesn't do anything. 2 negatives here makes positive, a regular 3, 1. There we go. That's the inverse of matrix A. That's the formula. Now, this can also be done on the TI-84 graphing calculator. If you go on the homework, the second video, there's 2 videos on the homework problem. The second video shows you how to do this on your TI-84 calculator. You can also go on desmos.com or some other website and do it easily online as well. Let's try number 2. Let's do the same thing. This one will be a little more interesting, I think. So to find the inverse, this is A, B, C, D. So here's the formula again. It's 1 over A times D. Multiply the main diagonal minus the other diagonal, B times C, times, and then you swap the main diagonal, put D here, A there, change the signs on the other diagonal. So there it is. Let's work that out. So 1 over AD, 0 times 0, minus B times C, 6 times 8, times, and now you swap the main diagonal. Well, nothing happens. They're both zeros. Change the signs on the other diagonal. Like that. Okay, let's work that out. See what we get here. So this is what? 0 minus 48. So it's 1 over minus 48 times 0 minus 8 minus 6, 0 equals. And now that number, that minus 148 multiplies all those, doesn't it? Any number multiplying the front of a matrix multiplies all the numbers inside. So minus 148 times 0, that's still just 0. This one will be minus 8 over minus 48, right? Because this is 8 over 1. And then here it multiplies to be, again, this is minus 6 over 1, so it'll be minus 6 over minus 48, and times 0 is just 0. One more step. Let's clean this up. So 0. This two negatives make positive. 8 goes into 48. 6 times 1/6. Two negatives make positive. 6 goes into 48. 8 times 1/8. 0. There we go, just like they said here. There is the inverse of that matrix. That's how we find the inverse of a matrix using this formula right here. And again, you can do this with your TI-84 graphing calculator. It is on the homework problem. It's the second video. You can also, it'll show you exactly how to do it, an inverse matrix with your TI-84 graphing calculator. You can also do it with desmos.com or other websites. Number 3, find the inverse. Now this is the inverse of a 3 by 3 matrix. How do we find the inverse of a 3 by 3 matrix? We do not do it by hand. I mean, you could go out there. There's videos that'll show you how to do it. It's terrible. It's just really, really terrible to do a 3 by 3 route. I gave you a formula for a 2 by 2 on the first two problems. I gave you a way of doing that with a 2 by 2. But for a 3 by 3, it's just way too tedious. It's terrible. I've taught it in the past. It's just really, really tedious. So we're not going to do it in this class by hand. We're going to use either the TI-84 or go to a website like desmos.com, free website that'll do it for you. So if you want to use the TI-84, if you go to the video in the homework, that gentleman there will, I think it's James Souza, will show you exactly how to do it on the TI-84. I'm not going to redo it here. He does a great job. He shows the TI-84 calculator on the screen and all the buttons you press and everything. It's excellent to show you how to find the inverse of a 3 by 3 matrix. Here's the answer. And if you don't have a TI-84, you can go to desmos.com. And it'll be real easy on that website also. Number 4, same thing. Not by hand. Not a 3 by 3. We do not do the inverse by hand. Again, the TI-84, or if you don't have a TI-84, go to the free website, desmos.com, and it will show you how to do it. Go to the homework problem, and there's a great video by Mr. Souza showing you how to use your TI-84, if you have one of those, to find the inverse. If not, go to desmos.com. It'll be real easy there to find the inverse. 3 by 3s, not by hand. All right, number 5. So now we're going to use matrices. Given the system of equations below, write a matrix system and then solve it. All right, so this is going to be nice. You'll like this. This is going to be an easier way to solve 3 equations with 3 letters. We did it earlier in this chapter. I can't remember which section, 7.1, 7.2, 7.3, something like that. We solved 3 equations with 3 letters, and it's pretty tedious. You know, you got to substitute, plug in, or use the elimination method. Yeah, I think I did elimination to cancel. You can get the z's to cancel and things like that. But now this will be way easier. We're going to see some of the power of matrices here and how easy we can solve for 3 equations, 3 letters, a system of 3 by 3. We call this a 3 by 3 system. This is a 3 by 3 system because there's 3 equations, 1, 2, 3, and there's 3 letters, 1, 2, 3, X, Y, Z. It's a 3 by 3 system is how that's called in the science world, math science world. So 3 by 3 system, 3 equations, 3 letters. So I'm going to do it with matrices. So the first thing you do, they're setting up for us down here a matrix equation. This is a times dot right there, and there's our equal sign. So what do they want us to do exactly? Well, basically, the first thing you do is you just peel off all the numbers. The 7, the minus 2, and there's a visible 1 there. So 7, minus 2, 1. Then you do the next row, negative 2, negative 2, negative 2, negative 2, negative 2, negative 2, and then negative 4, negative 5, negative 1. Negative 4, negative 5, negative 1. So you just peel off all the numbers. You put the x, y, z right there, and then the numbers on the right side, you write them over here on the right side. Minus 51, 18, 52. So we just turned this 3 equations with 3 letters, 3 by 3 system into one big matrix equation. It's a big old matrix with numbers times a matrix with letters equals the answer matrix with numbers. Now, why can we do that? Well, that's actually true. Think about what we've learned about matrix multiplication. This is if I was to multiply, just forget about this right side for a minute. What if I was just to multiply these two? What would I get? What is this? Remember how to multiply? What we learned about multiplying matrices? None of this is necessary. I'm just going to show you why this is true. This is a 3 by 3. This is a 3 by 1. Remember, you go down first and then across. That's a 3 by 1. The order matters. Down first. So the size of this matrix is 3 by 3, and the size of this matrix is 3 by 1. So if I was to multiply these two matrices, would it be okay? How do you know when you can multiply two matrices? If the two inside numbers, they're the same, so you can multiply. As long as the two inside numbers match, you can multiply. The size of the answer will be what? The two outside numbers. 3 by 1. Okay, great. So what? So the size of the answer will be 3 by 1. Yes, it will. And so it'll be 3 down, right? 3 down by 1 across. Let's do it. Let's find out what it is. Again, none of this is required. I'm just showing you it's true. So where would we start? We start in the top row and we go down. So 7 times x, 7x. And then you jump to the right and jump down, always. Negative 2 times y. To the right, down, plus 1z. Look familiar? 7x minus 2y plus 1z. And then you do the second row and do the same thing. Negative 2, start at the top again, times x, etc. You're going to get all of these right back equals to the right side. So my point in that is I'm just showing you that all of this times all of this is all of that. I've really scribbled this up now, but I hope this is making sense. Let me clean up this big terrible mess here now. So what I'm saying is that when you peel off those numbers, almost got this erased. So when you peel, let me put these back here. 7 minus 2, 1. There's a 1 here, right? Minus 2, minus 2, minus 2. And minus 4, minus 5, minus 1 there. And then times x, y, z. And you put over here minus 51, 18, 52. If you multiplied this times this, you would get this back. We just saw it start to happen. It's the same thing. This times this is this, based on the rules of matrix multiplication. And they all equal, so it equals those three. This matrix equation is identical to this original 3 by 3 system, 3 equations, 3 unknown. We've done the same thing. We've just written it a different way. We've written it in matrix language instead of writing it in the original 3 by 3. It's like saying one or uno. You're saying the same number in two different languages. You're saying the same thing in these two different languages. 3 equations, 3 letters, or one big matrix equation. It's the same thing, as we saw when we multiplied them out. Okay, so what? Great, so it's the same, and yeah, okay, great. Well, this will make it easier to solve. That's why it's great. It's a lot easier to solve this matrix equation. How so? How do we do it? Well, I want you to think in terms of a normal equation. Just pretend this is a big number. In the matrix world, it's a big number matrix. What if you had a big number, I don't know, like, 10 times, and then this is like a letter, x, equals, and then some number over here like 7. Imagine you had the equation 10 times x equals 7. That's basically what we have in matrices, in the matrix world. That's the equation we're looking at. Let me just make it a normal number equation. How would you solve this normal equation? How do you solve 10 times x equals 7? You know how to solve that, right? You just divide by 10 right away, and you'd have x alone. You'd be done. Right. So in other words, we just need to divide by that matrix that's in the front, and then we'll get the letters alone, and we'll have our answers. Great. So how do we divide in matrices? How do you divide a matrix? How do you do that? Well, remember what I talked about back on problem number 1. If you listen to that part of the thing, dividing is multiplying by the inverse, isn't it? Right? 10 divided by 2 is 5, just like 10 times a half, right? Here, let me write it this other way. 10, well, it doesn't matter, same way. 10 divided by 2 is 5, just like 10 multiplied by a half is 5. Dividing by 2 is multiplying by the inverse. This is the inverse of 2. A half is 2 inverted, isn't it? It's the inverse of 2. So in other words, dividing is just multiplying by the inverse. So if we want to divide by something, you just multiply by the inverse. In other words, I could have done that back here. Let me show you. Let's go back to the 10x equals 7. And what we could have done is we could have multiplied by the inverse 1/10 on both sides. That'll still cancel because this is really 10 over 1, right? Any whole numbers over 1. These would cross cancel. Remember, cross canceling fractions. That would work just as well. Again, the 7's over 1, so 7 times 1 is 7, 10 times 1 is 10. Same answer, same thing. Dividing by 10 is the same as multiplying by 1/10. Dividing by a number is the same as multiplying by its inverse. So that's how we solve a normal equation, is we multiply by the inverse. So let's do the same thing with this matrix equation. That's exactly what we're going to do. That's how we're going to divide and solve it. So let's do it. So coming back here, this is I'm going to call this matrix A. So we basically have matrix A, just making up a name here, times matrix X is matrix whatever, let's just call it number. So matrix A times matrix X is number. So I have A times X is number. And I want to solve that matrix equation. What do I do to get rid of that A? Well, you might say, well, divide by A. And divide by A on both sides. Right. You want to divide by A on both sides. That'll get rid of it, and that'll get X alone. You'll have your answer for X. But how do you divide by a matrix? What is dividing really? It's upside down multiplying. It's multiplying by the inverse. So the way I divide by A here is I multiply by A inverse. And whatever you do to one side of an equal sign, you have to do the same thing to the other. I'm kind of running out of room here. Let me put a little more room there. You got to do the same thing to the other. If you put A inverse multiplied on the left side, then you got to put A inverse multiplied on the right side. And what will happen is these will cancel out, won't they? Because it's the inverse. It's like dividing by A. They cancel out, and that gets X alone. And what will X equal? A inverse times the number matrix. Do you get that idea? That's what we have to do. We're going to do it on the calculator, but I want to make sure you see that. So, again, this is a big matrix equation. Matrix A times matrix X equals number. A times X is number. And the way to get rid of the A so that X can be alone, you can solve for X, is you multiply both sides by the inverse of A. Multiplying by the inverse is the same as dividing. So when you multiply by the inverse, it cancels out a, because this is like a divided by a. It cancels out, get x alone. So what will x equal? The inverse of a times the number matrix. So that means I need to take this matrix A, and I've got to find the inverse of it, and multiply it by the number matrix. This is the number matrix over here. So how do you find the inverse of A? Well, I'm kind of running out of room. Let me put it up here. I'm going to do that on my calculator, my TI-84, or you could go, if you don't have one of those, you can go to desmos.com. So the A inverse matrix, if you want to do it on the TI-84, if you have a TI-84, you can do it on the TI-83 or 84. Just look on the video I connected to this homework problem. If you go back to this homework problem, the second video will show you how to cancel out the how to use the TI-84 calculator to find an inverse matrix. If you don't have a TI-84, you can go to desmos.com, free website, you can find the inverse. But here is the answer for the inverse matrix from the calculator. I got decimals at first and I changed them to fractions, and all that is shown to you on the second video. So it's 4/33, 7/66, minus 1/11. This is a messy one. And then second row, minus 1/11, 1/22, minus 2/11. Third row, minus 1/33, minus 43/66, and 3/11. So there we go. There's the inverse matrix from the TI-84 calculator, or you could also get it by going to desmos.com, and you could just use a big decimal one. So what am I going to do now? I'm going to take that inverse matrix and I'm going to multiply by this number matrix, which I don't have room to do. I'm going to have to squeeze this in a little better here. So negative 51, 18, 52. So you're going to multiply, right? Because that's what was our conclusion. The inverse of A times the number matrix. X alone, right? We multiplied, we took this matrix equation, we multiplied both sides by the inverse, canceled out the A inverse and the A, canceled out on the left side, so X was alone. And on the right side, we have the inverse of A times the number matrix, the inverse of A times the number matrix. Again, I'm going to do all this on my graphing calculator, my TI-84 calculator. So to multiply those matrices right on my calculator. And when I do that, when I multiply these on my graphing calculator, here's the answer. You can see it right down here. Here's the answer I get on my graphing calculator. It ends up, the solution ends up equaling, they want you to write it -9, -4, 4. It ends up being a matrix, it looks like this. It equals -9, -4, 4, and then we write it like that. So there we go. All I did was I multiplied this big old matrix, that answer, that A inverse, times the number matrix. A inverse times the number matrix. The order matters. You have to have the A inverse come first, then the number matrix. Why? Because that's what I did on the left. I put the A inverse on the left. I've got to put the A inverse on the left on the other side as well. So you got to do the exact same thing to both sides. A inverse on the left, A inverse on the left on both sides. A inverse times the number matrix. The order matters. For matrices, we're not used to that. For normal numbers, the order in which we multiply never matters. But for matrices, it does, because of all that size stuff and the down first, then across. So you got to keep the same order. If you multiply on the left, we'll always do the left. On the left, on the left. So A inverse times the number matrix will be this answer. And so we got it. This is X, this is Y, this is Z. We just solved the whole system. We found X, Y, and Z that quick, that easy on the graphing calculator or on Desmos.com. So again, I encourage you to, really the gentleman, James Souza, that did the video on the homework, showed all the steps on the graphing calculator. So I didn't show that here. So his is really a better video, going to be more helpful. So I encourage you, go to the homework, click on the video there. In fact, I think I'm just going to leave one video there. He does such a good job. You don't forget about the second video. Just use his one video. He shows the whole thing on the graphing calculator, how to enter everything and find the inverse and multiply by the other matrix. He does a beautiful job. Just use his video right there on the homework, the video attached to the homework, and that'll help you. And it'll show you how to do it in the calculator. And if you don't have a TI-84, you can go to Desmos.com and basically do the same thing. Number 6. So here we go again. We're going to solve 3 equations with 3 letters using a matrix equation. So you know what we do? We just peel off the numbers first off. So -6, 2, 9, and 2, 2, 2, and -8, -8, 1. -8, -8, 1, like that. And then these 3 numbers go on the right side, -101, 0, -99. So this is matrix A. We'll call this matrix X, and we can call this B, whatever. You can call it whatever you want. I'll just call it B. So basically we have a matrix equation, which is the same as our original 3x3 system. 3 equations with 3 letters. So we have matrix A times the X matrix is the B matrix. So it's a matrix equation. And so how do you solve a matrix equation? You multiply on the left, both sides, multiply the left. Remember, the order matters. You can't put the A inverse over here on the right. That'll mess it up. Why? Well, because you got to do the exact same thing to both sides, right? If these 2 sides are equal, and you treat them exactly the same, they'll be equal when you're done, right? You understand that idea. You feel the truth of that. If 2 things are equal and you treat them the same, they'll be equal when you're done. How do you treat them the same? You multiply A inverse on the left and A inverse on the left. You can't suddenly go over here on the right. Now you might think, well, does it matter left or right? For matrices, it actually does. For normal numbers, we know, 2 times 3... 3 times 2, whatever, it's 6 either way you do it, it doesn't matter. Yeah, that's true for numbers, but that's not true for matrices. Matrices, the order matters. So we're multiplying A inverse on the left. Why? Because we want it to hit the A, and then these will cancel, and X will be alone. So if we do it on the left on that side, then we have to do it on the left on this side. So basically, put this into your graphing calculator as matrix A. Put this into your graphing calculator as matrix B. And then on your, or Desmos.com if you don't have a TI-84 graphing calculator. And then take A inverse on your graphing calculator. Hit the X to the -1 inverse button. Multiplied by matrix B. And hit equals, and boom, you'll have your 3 answers, which are right here, 3, 8, -11. They want you just to list them with commas. You'll get your 3 answers that quick. There's X, Y, and Z. That fast, you're done. I didn't show the TI-84 graphing calculator steps here. It's on the homework problem. Use the video. Mr. Souza does it on the homework problem, the video attached to the homework problem. He does a great job. He shows how to enter this in the matrix A and B in your calculator and do the inverse column forward and do all this. It's all there for you. Number 7, one more of these, which is exactly the same as the other ones. So we're going to we're going to peel off the A, the B, and the C. So, or we're gonna peel off the numbers. So 2 minus 5, 1, 2 minus 5, 1, and minus 1, 1, minus 1, and 1, minus 3, and oh, we don't have a Z. That's 0. See how we're missing this? This one is really x minus 3y plus 0z is negative 12. You see that? There's no z. So if somebody's missing, it's a 0. Times the matrix, the column matrix x, y, z equals the answer matrix over here. Minus 23, 8, and minus 12. So there's our matrix equation. So put this one into matrix A, this is matrix X, and this is matrix B. So we have matrix A times matrix X is matrix B. How do we get X alone? How do we solve for X? We multiply on the left, on both sides, A inverse, don't we? That's how we divide. We multiply by the inverse. And that cancels out and gets X alone. So take your TI-84 graphing calculator and put in matrix A, right? This is matrix A. And hit the inverse button times matrix B. This is matrix B. And hit equals. And you'll get these three answers, minus 3, 3, and minus 2. That quick, you'll have the answers for X, Y, and Z. Now, I'm not showing any of those steps. I didn't show the graphing calculator because it's on the video that's on the homework. So use that one. He does a great job. He shows you how to put in matrix A, how to put in matrix B, how to call them forth with the inverses and all this stuff. And it just cranks out the answer right away for you. Number 8. Okay. An investor has found 2 investments that he wants to invest in. The first one pays 10% per year, and a more risky investment pays 21% per year. He has $39,000 to invest and would like an annual income of $6,980 per year from his investments. So the question is, how much should he invest in each account? We're going to let X be the amount he should invest at 10%, and Y be the amount he should invest at 21%. So we got to figure those out. So the first thing to do is write, the 2 equations. If we have 2 letters, we need to have with it 2 equations. So what's my first equation? Well, $39,000 total is going to be invested. So we'll just do invested. So dollars invested, that'll be X plus Y is 39,000. And the next equation is going to become is the percent interest, or the percent that it pays. Let's put it that way. So the first one pays 10%, so that's the X, so 0.10 times X. So however much money is invested in the first account, X, times 10% of that investment is what will be paid. Plus, the other one is 21%, so 0.21Y. However many dollars Y are invested in the second account times 21% of that amount. That's going to add up to be the income of $6,980 per year. Okay, so there's our 2 equations with 2 letters. Now we're gonna solve this with matrices. See how it says using inverse matrices? So I'm going to turn this into a big matrix equation. Remember how that works? We just peel off the numbers 1, 1, 0.10, 0.21 times the xy. You put the xy as a column matrix equals, and then the numbers on the right side, 39,000, 6,980. So we turn it into a matrix equation. You put this one into matrix A, so type into your TI-84 graphing calculator. If you look at the second video on the homework problem, so if you go to the homework problem number 8, you'll see there's a video, the second video. That's the one where it'll show how to use your TI-84 calculator to solve this matrix equation now. Because I'm not going to show it here. I'm just going to say put this matrix in as matrix A, call that one X, put this one in as matrix B. So put those into your graphing calculator. If you don't have a graphing calculator, just go to desmos.com, free website, just use their graphing calculator stuff. Now how do we finish solving this equation? AX equals, we want to get x alone, right? So to get x alone, you got to do the inverse of A, and you got to multiply the inverse on the left side, on the left of both sides. So it cancels, that gets A alone. That gets x alone. So type into your, go to your graphing calculator or Desmos and do A inverse times B and hit equals. And you'll get the two answers for x and y. You'll get 11,000 and 28,000. It'll just pop up for you. That's how we do that problem. It's quicker that way. All we need is the matrices to solve it. Let's try number 9. So same kind of thing. Notice we have, I'll call it stocks, bonds, and CDs. We're trying to figure out how much should be invested in stocks, bonds, and CDs. Now we know if there's 3 letters, there's got to be 3 equations. So let's write our 3 equations. Here we go. The Country Days Scholarship Fund receives a gift of $105,000. So they're going to invest that in stocks, bonds, and CDs. So our first equation is stocks plus bonds. Let me do a little more room there. Plus bonds plus CDs is 105,000. That's just the total amount of money that's invested in stocks, bonds, and CDs. That's the total dollars invested. And now, next equation is going to be all about the pay, what they pay. The CDs pay 5.75%, so that's going to be 0.0575C. The bonds pay 3.6%. So we'll move the decimal back 2 places, 0.036B. The stocks pay 11.7, so that's 0.117S. And that all adds up to equal, what is it? The annual income, this is what they get paid, this is their pay, their income, is $6,450. Oops, kind of running out of room here. Is $6,450. So now the third equation is Country Day invests $20,000 more in bonds than CDs. So the bonds is 20,000 more than CDs. 20,000 more in bonds. The bonds equal 20,000 added to the CDs. That's our third equation. So there we have 3 equations with 3 letters. Now, the deal is we have to put these things in order. Do you see how we have S coming first and then B and then C, and here, same thing here, S, B, See? Well, we've got to get them in order on this third. This third equation's out of order. So I got to grab this C and jump it to the other side of the equal sign. See how we have to have S, B, and C on the left side of the equal sign and the numbers on the right side of the equal sign. So I got to jump that over, so this will become B minus C is 20,000. So that means 1B, well here I'll just leave it like that. So I just subtracted that C to the other side of the equal sign. Really I could have just done minus C from both sides of that equation. Canceled it out here, made it B minus C on the left side of the equal sign. So there's our third equation. Now we're going to solve this with matrices. So let's write a big old matrix equation. Just peel off the numbers 1, 1, 1, 1, 1, 1. So it'll be easier this way. 0.117, 0.036, and 0.0575. And the bottom? Now what goes in the bottom? There's a 1 on the B and a minus 1 on the C. But remember, this is the S, B, and C columns, right? S is first, then B, then C. So what's S? It must be 0S. There's no S at all, so it must be 0S because S is missing. It's 0 times S. So it's 0S, 1B, minus 1C. There we go. So we had to line things up, get the S, B, and C on the left, the numbers on the right, times S, B, C. There's the matrix equals, and what are the three numbers? Well, they are the right side over there, which is 105,000. And the second one is 6450. And the third one is 20,000. So there's the three. All right, so there's our matrix equation. So now you know how this works, right? This is matrix A, this is the X, this is the B. So put those in your calculator. So take your TI-84 graphing calculator. If you don't have that, go to desmos.com and put them in. Now, if you're not sure how to do that, look at the second video on the homework. This is homework problem number 9, section 7.7. So go to number 9, look at the second video, and it will show exactly how to put this matrix into your calculator. Put in matrix B as well. And now how do we solve for X? We're trying to get X alone here, right? Trying to get X alone. We want to get rid of the A. We have A times X equals B. And we want to get X alone. How do we get rid of the A so that X can be alone? You multiply both sides on the left by the inverse. You put an A inverse on the left for both sides, and it cancels out, and that gets X alone. So that means on your calculator you need to go A inverse on your graphing calculator, A inverse times B, and hit equals. After you've already entered matrix A and matrix B into your graphing calculator. Again, the second video on the homework number 9 will show exactly how to do all that. Hit equals, and you'll automatically get those three answers right there. There we go. 25,000, 50,000, and 30,000 will pop out. Much easier way to solve three equations with three letters.